Okay, guys. So thank you for the warm up for doing the warm up. Now we're going to do something a little bit different, and these notes are going to be a little more detailed. So what you're going to see here, as you're reading the essential question, of course, writing that essential question down. What we're going to see here is how to take this transformation rule that we know has something to do with like a perpendicular bisector if you're reflecting, vectors if you're translating, and of course a circle and an angle and a center of rotation if you're rotating, and to do something ultimately more useful, which is plotting something on a grid. And so that's what these notes are about. So we're going to see how to decode it as you're seeing in the essential question. How do you decode a formal transformational rule to a more useful coordinate rule, and then use that coordinate rule to plot a transformation on a graph. That's what we're going to see. So if you can do that by the end of these notes, you won the game. So let's jump into it. So the first thing that we have to do is realize what we're looking at, and it's going to be a lot of mathematical kind of language here today. But what we're actually looking at right here is a formal translation rule. And so immediately you should be thinking, well, it's a translation, so we have to have a vector. So we're going to be sliding, because it's a translation, along a vector. And so this rule somehow has to tell us that information. And so our first job is to decode it. So let's jump into the coding part. Well, the T is just a way to tell us that we actually have a translation. So T stands for translation here. This part right here is going to speak to the vector. ABC is going to be the preimage. And then this implies that we're doing some kind of mapping, some kind of transforming onto a target, which is going to be the image A prime, B prime, C prime. Now it's also important to note here that we're going to have a direct mapping one-to-one for points. And so this rule is going to tell us exactly how to take the first point, move it to its image, the second point, move it to its image, and then the third point. Now, not just because they're named the same, but because they're in the same position. The three target points are going to be A to A prime, B to B prime, and of course C to C prime. The letters are going to change, and so it won't always be so obvious, so you have to think of it kind of as a positional thing. Okay, excuse me. The important part for us is going to be decoding the vector. Because this is going to be on a grid, this vector actually has to tell us how to move coordinate points. And so there's no secret here, there's no mystery. These notations, these brackets, are the vector brackets, but the inside work just like coordinate points. And so this first one speaks to the x, the second one speaks to the y. And so if you can hold that association, that even though we have these vector brackets, which are kind of like these arrows, the numbers inside actually tell us how to move. It's not a point to plot, but it's going to coordinate very, very well with what we're used to seeing. So let's see how that looks. And so if that's the formal translational rule, which is how you're going to get a lot of information about what to do, we immediately have to move that into our coordinate rule. Okay, so again, we have to do a little decoding here, and there is going to be a relationship between the two. And so you notice the blanks, those are actually going to come directly from the vector. And so xy is going to be our pre-image point. It's going to be the point at which we are starting. This is going to be our image point, this entire thing, which I just kind of expanded because I had to do some writing. And then the inside part, we're going to get directly from the vector. And so if this vector is negative 2, 3, and 2 corresponds directly with the x, okay, so this negative 2, this negative 2 right here corresponds directly with the x, that's going to tell us how to change the x to something brand new. In this case, because it's a negative 2, we're going to take x minus 2. And so what that basically means is we're going to take the x value, whatever it happens to be, and just subtract 2 from it to get our new image point. And then we can code in the let's use red. We can code in the y the same way, and so like the y is going to be a positive 3, and so that's going to tell us to take our pre-image y and then change it, in this case, by adding 3, because it's a positive 3. And so the vector, which was negative 2, 3, shows up as a negative 2 shows up as a negative 2 here, and the positive 3 for the y. And so now we have to take this coordinate rule and figure out what to do with it, right? So if we had to describe algebraically what to do to each coordinate based on the rule above, well, that's pretty straightforward. We're going to take the x, so each x gets subtracted by 2. And each y gets added by 3. Right? That's pretty easy. That's pretty straightforward. And so if we take that now to an actual gridding, and so this is a table for the triangle on the right, we should probably first fill in our rule, and so xy is going to be now x minus 2, take the previous x, subtract 2, and the y is going to be y plus 3, take whatever you had for y, and then add 3 to it. And so in terms of our calculations, this is pretty straightforward. So we have this 3 as our first x, because remember these are x comma y points, and so our new calculation will be 3 minus 2, and that comes from this minus 2 part. Okay, so we have this x minus 2, that's why we have the minus 2 there. The 3 came from directly from the original 3. Then we're going to take this y, this 6, and we're going to take 6, in this case add 3. Again, if you're wondering why we're adding 3, it's because of our rule. The vector told us that it's a positive 3, hence add 3. That's going to translate to the plus 3 right there. And so our new coordinate, and we started off at a 3, 6. Now we're going to end up with 3 minus 2, which is 1, and 6 plus 3, which is 9. And so the way that plays out for us is that we now can plot a new point 1 comma 9. And so we come over to the grid, over 1 plus up 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to be our new A prime. Okay, that's what we had labeled here. Now, we should be able to track this immediately to see if we did it right. If we are correct, if we connect the A to A prime, with a vector symbol, of course, we should see the movement the same as the vector. Keep in mind the vector in question was negative 2 comma 3, which basically means that we're moving left 2, and then we're moving up 3, because minus 2 on the grid for the x's, because keep in mind that's the x and that's the y. So minus 2 on the x's would go to the left, and then plus 3 for the y's, which that's a y of course, is going to go up 3. And so the AA prime vector does hold to what the original numerical vector was. Now we can just do that a couple more times. Okay, so we take our original value of 7, we'll subtract 2 for our vector rule. Then we can take our original value of 4 for a y, and then add 3 to it, to complete our vector. And so what was once a 7 comma 4 is now going to be a 7 minus 2, which is 5, and then 4 plus 3, which is 7. Now again, we can test this right away. We should map it out. So 5 comma 7, so 1, 2, 3, 4, 5 on the right, and then 1, 2, 3, 4, 5, 6, 7 for a final B prime point. Now let's go ahead and vector this. We should be able to now check it a couple different ways. One, did go back 2 and then up 3 as a vector, of course, but also if you compare the two vectors, they're actually parallel and they're congruent. The slopes on both are down 3 over 2, down 3 over 2, that makes them parallel, and you can visually check right here, since we're on a grid, like those are definitely the same length. So we're definitely doing a really good job here. Let's do one more. Let's go with purple. No, we already used purple. Let's go with brown. So our original point, which was a 1, gets a minus 2 from the vector. And then our other point, which also is a 1, now gets a plus 3 from our vector rule. Okay, and so this new point ends up being a 1 subtract 2, which is a negative 1, and a 1 plus 3, which is a 4. And so let's map out C prime. And so let's go, where is it, negative 1. So we'll start at the origin, go back 1, up 1, 2, 3, 4. Okay, and that's going to be our C prime. Immediately, let's draw in the vector of movement here. Boom. That vector is definitely parallel and congruent to the rest. And so now we can actually commit to the figure. So we just connect C to A, to B, A prime to B prime, back over to C, and now we can actually compare the two triangles. And so you might notice the triangles definitely look like they're congruent because they should not have changed shape. This is a rigid motion. But also the vectors themselves we can mark to be both congruent and parallel, okay, with the chevrons. Okay? And that's the ball game for translations. And so with a quick review before we move on to the next piece, T for translation, the vector of movement, which is just x comma y because we're moving on a grid, takes a pre-image and maps it to the image. The negative 2 comma 3 directly correlate to x and y values, but it's not a point. Instead, it tells you how to change the x and y values. -2 means take 2 away from the x. That's a left-right movement. The three that corresponds to the y says take y plus 3. That's an up and down movement. And so essentially what you're doing is taking all the x's -2, all the y's +3, which the end result are some new points, but really the whole shape is just moving to the left 2 and then up 3, and then that's the whole thing. If you can do that, you're going to be super successful with translations. And so let's do a little cleanup here. So on a translation, the lines, and if you do recall, the lines are something we're going to call vectors. Okay, that's the green lines up here that connect the image and the pre-image. That connect, oh, look at that, the pre-image and the image. Okay, are always going to be, and you guys know this, they're going to be parallel and congruent. And so that's actually is going to make the shapes congruent. And so like that distinction is actually really, really important. So we've been talking about 11 minutes now, so this is a good time to take a brief break. But part of that break, when I say brief, I don't mean for the next 25 minutes, but take a small brain break from my voice, pause the video, and summarize what you have read. That way you can use these notes moving forward on a test or quiz that I'm sure is coming next. Okay, so pause the video, do that, and let's talk about reflections. Okay. So let's start with this guy. Okay. Now, this is going to be a reflection formal rule. We should also note, like this R, which is what stands for reflection, it can be a little r too. It's a little ambiguous. Ambiguous means it's hard to actually tell. But the big part, the way you can tell apart, is that the information that follows that's subscripted here is always going to be a line. Remember, the y-axis is a line, the x-axis is a line. It could be an equation, but we are taking the pre-image and then we're going to map it to the image, right? And so we know it's a reflection, so we know it's going to actually flip. In this case, it's going to flip over the y-axis. And if we want to fast forward here, just as a reminder, the y-axis is indeed this line, okay? So that's going to be the y-axis. And a lot of our work is going to be over axes, because if we can flip over axes, we can flip over basically anything. But that's what's going on. So we're just going to take this triangle ABC and we're going to flip it over the y-axis to this new triangle A prime, B prime, C prime. Okay, so you can definitely fill out those two pieces now. So let's translate this now to a coordinate rule. So the coordinate rule. So the coordinate rule, again, one comes from the next, so we just have to do some decoding. And so this is really just about having, the right geometric thing. Now, if we're going to just flip it, and we can probably make a little bit of sense of it, if we're just going to flip it over this line, okay, what we're going to have, what we're going to have is really just a movement left to right. And so what was over here at A should end up over here at A prime. If we just kind of investigate this a little bit and think about the coordinates, A is at 2, 1, 2, 3, 4, 5, 6, 7, 8. So this is at 2, 8. Well, if this is flipping over the red line to this new A prime, which we could have predicted without anything fancy, we can already coordinate this. This is just going to be -2, 8. And so if you compare the two coordinates, the only thing that's really changing, to be honest, is going to be the x value. That's it. And so that's going to help define our rule, because if all that's changing is the x value and the y stays the same, that means our coordinate rule for y-axis movement is going to be to take the x value and then change it and then keep the y value the same. So it's important to note in this context that all that actually means is change the sign. So in other words, if it's positive, make it negative, or vice versa. Okay. So what's going to happen algebraically? Well, that's what's going to happen. So we're going to keep the y value the same, and we're going to change the x value. So take a second and summarize that in your own words right here. What's going on? Now, if you didn't get it, pause the video or rewind it, watch that part again, and hopefully that will make a little more sense, right? So let's repeat this rule here. So we're just going to take negative x comma y. And so there's not a calculation to do here, right? So I'm just going to kind of leave this empty, this part in the middle blank, because it's really just about reading it. We're just going to take this negative 2, or I'm sorry, this 2 and change the sign to a 2, and we're going to keep the 8 the same. Okay, so like if there is any calculation here, it's going to be change the sign, and this is going to be stays the same. Now, I'm getting that directly from here. And so there are other rules for reflection, and you're going to see that here before too much longer, but that's what's going on. And we're just going to change the sign, and then we're going to stay the same if we're going to flip over the y-axis. And so we can copy this here, because the same rule should apply for all the points. All the points should translate or map the same way. We already actually mapped that one. Let's map the next one. And so 5, 5, we're going to change the sign of the 5 to a negative 5, and the other one is just simply going to stay the same, and that's going to be our b prime. Now we can predict, since we're flipping over the red line, if we did it right, so we're going to map 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, there it is, boom, that's going to be our b prime. And it looks like it actually could have reflected over the red line because it's just flipping point to point. Last one, we have negative 4, which we have to change the sign, so that's going to change to a positive 4. Negative 1 stays the same, so it's going to be a negative 1. Cool. And so C, we're going to go over 1, 2, 3, 4, down 1, there's our C prime. Now, this one may be a little bit hard to visualize, but since we know a little bit about reflections, let's first map our new triangle. Okay. And so because we're kind of crossing over the axis of reflection, it's going to do a little bit of kind of like a twist to it, but we can definitely see this as reflected. Now, if you recall from our warm-up, the only surefire way to know that is if this actually is a perpendicular bisector. And so if we connect BB prime, AA prime, and CC prime, we know that we did this right if two things occur. One, you always have a right angle, which we do. We don't have to calculate the slope to tell it in this case because they're straight up and down, straight left and right, horizontal and vertical. We should also have bisection, excuse me. Well, this is 2 grids long, that's 2 grids long, so that definitely works. That's 1, 2, 3, 4, 5 long to the axis of reflection, 1, 2, 3, 4, 5 to the image, or the pre-image, excuse me. And so those are definitely congruent, and then 1, 2, 3, 4, 1, 2, 3, 4, yeah, so these are going to be congruent as well. And so remember, reflections need perpendicular bisectors the same way that these need parallel and congruent vectors. In fact, let's go ahead and write that. Remember, these are going to be parallel and congruent vectors. Okay. This has to be a perpendicular bisector, which we, by observation, can definitely tell has happened. Okay, so this y-axis is axis of reflection, which is another thing we can call it. A line of reflection. Okay, also the axis of symmetry. Let's throw another word in there. Okay, axis of symmetry, line of reflection, perpendicular bisector. This is how you prove it's actually been reflected. And so kind of from the top, reflection R, it could be a little r, by the way. Sometimes you'll see it. This is going to be the line of reflection. I didn't put that. That's why we review and process our notes. Takes a pre-image and maps it onto the image. And so the way it does it is by this extremely formal rule where we're going to keep the x, we're going to change the sign of the x and keep the y the same. Okay, make sure you've written that in your own words here at some point. Just don't copy mine. Note taking is about you too. So this is a place we can formally process the rule where we definitely change the sign on the first value because that's what it demands of us in the rule, and we kept the second one the same. And then we map it. And the way we can confirm our mapping, so you never really have to ask me if you did it right or not, is that if you can draw these perpendicularly bisected lines, and it really is perpendicularly bisected, you're good to go, man. Like, that's going to be your reflection. So let's do a quick wrap-up sentence and then give you a chance to summarize. On a reflection, the line that connects, let's go pre-image, like A, B, and C, to the image points, A prime, B prime, C prime, are going to be blank to the line of symmetry and blank by the line of symmetry. So they're going to be, let's see, it should be a perpendicular and bisected, so they should be perpendicular to the line of symmetry and it's going to be bisected by the line of symmetry. Okay? And so, again, this is the opportunity to pause the video and summarize notes before going on. That's going to give you a small brain break before we talk about rotation. Okay? So please do that and rejoin us in just a second or two. Okay. All right, so last bit. So now they have summaries for both of them, which means you can use those on tests and quizzes, which is why it's good to pause the video and do that. Let's talk about the formal rotation rule. Okay, so the formal rotation rule, let's decode it first. And so that again is going to stand for rotation. That can sometimes be a big R instead of a little r. Those are kind of used indistinguishably, but the way you can actually tell them apart is by this bit right here. This is not going to be a line because rotations, remember, don't need lines. They need points or centers of rotation, which is what that is. That's a center of rotation. Sometimes that's going to be a point. In this case, it's an O because this actually stands for the origin. And the origin in this case is 0, 0. That's a shorthand. And the 90 part is going to be a degree of rotation. And so if you think about the warm-up, how he drew those lines back to the center and they all had the same angle, that's going to be what this is. So this is going to be the degree or angle of rotation. Okay, and so again, that's going to be the pre-image. This implies that you're mapping, and that's going to be the image. And so what's going to happen here, like if I had to describe the transformation in my own words, hint, hint, nudge, nudge, that means we're taking this old triangle ABC, we're spinning it around the origin 90 degrees, and we'll talk which direction here in a moment, from this triangle to this new triangle. And none of the points should be the same point because they're all mapping onto these new primes. Okay? So let's talk about the coordinate rule then. So the vector for translations told us what to do, but for reflections, we can kind of make some sense of it, but in the end it was rule born. Rotations are the same way, so depending on the degree of rotation, you're going to have a different rule. And so the rule for this one, if we're going to rotate 90 degrees, we're going to take this xy and we're going to change it to negative y comma x. And so this is probably the weirdest one. Rotation rules are the weirdest, the easiest ones to kind of mess up because they're very specific for a degree of rotation. And so you should note that this is only true if, and I'll throw in a second F in there, so in geometry, IFF means not only kind of like kind of, it means only if this happens. It stands for if and only if. So if and only if the center is at origin, okay, and you're rotating counterclockwise. And so I'm going to put an abbreviation first, CCW, and that stands for counterclockwise. Now this may be a new term for some of you guys, counterclockwise. And so if you're confused about counterclockwise, look literally at the clock above my desk, the old school analog clock. So please notice the way that the hands are spinning and the way the second hand's spinning. That's what we refer to as clockwise, kind of like to the right hand side. Counterclockwise is going to be the default. And so when we talk rotations, this is always going to be the default direction. Okay? And that's just assumed by the math world, that if you're always rotating, you rotate counterclockwise unless you specifically say you're rotating some other way. Okay, and so like what does this mean algebraically? Well, three things are actually going on. So there's three things algebraically that's going on. I'm going to help you this part because it's a little more complicated. So one, you're going to switch the x and y. Okay, so you're going to do a quick flip-flop. Two, you're going to change the sign on the new x. Okay, and so the new x used to be the y. Try and draw an arrow. So used to be the y. Okay, and the third thing you're going to do is you're going to keep the sign on the new y, which used to be the x. Okay, now I know that is super confusing, so let's actually put that immediately into action. And so, so the rule here, let me copy it, is negative y comma x. And so we're going to do three things. We're going to switch the x and y, and the thing that's now in the x position gets the sign change, and the thing that's listed second in the y position does not. Okay, so let's make this happen. So we're going to do all these things at once here. So we're going to switch. Okay, so switch the x and y, and then we're going to change the sign here. Okay, and we're going to keep sign here. And again, sign just means positive or negative. And so what used to be 7 comma negative 4, we're first going to switch. That's this first part. And so the negative 4 is now listed first, and the negative 7 is listed second. But whatever is listed first, we're going to change the sign on. So it was a negative originally, and so now it's going to be a positive. And the negative 7 is just going to stay the negative 7. Okay. Now this is again the most confusing and the one that we probably have to depend the most on, like our visualization to help us. But a prime should now be at 4 comma negative 7. So let's map it out. So 1, 2, 3, 4, and then down 1, 2, 3, 4, 5, 6, 7. So here's going to be our a prime. Now this is going to be really hard to tell if we're doing this right, but we can start mapping the angles. The circles I'm not going to map because it's going to be too messy, but it can track the angle. Now remember, the center of rotation is going to be the origin, which is the center where the center of the place where the two axes are going to intersect. So this right here is going to be our center of rotation. Okay, and it's also the origin, which is a common spinning point. Origin, coordinated by 0 comma 0. Okay, now here's the good news. We actually, just based on what we did, I think we did it right, because this angle should be the angle of rotation, which is 90 degrees. We should be able to see the angle of rotation. Also keep in mind the rotation was going to be counterclockwise, and so if we're moving from A to A prime, that means we're moving in the direction of the arrow I just drew, and that's opposite of what a clock does. Hence, it is counterclockwise. So I feel good about what we just did. Okay, so let's do this again. Actually, let me just copy this real quick. So we're going to switch and copy. I'm just going to write it one more time, kind of in between, right? Okay, so we don't have to do it every single time. Let's not use red. Let's use blue. Okay. So let's do these three things again. So one, we're going to switch. So switch these up. So the negative 1, which is now second, is now listed first, which means we got to change its sign to a 1 instead of a negative 1. Negative 2 gets switched to the back. Its sign stays the same, so it's going to be a negative 2. So let's graph this out. So B is going to graph to 1 comma negative 2, which is actually right there, kind of on top of each other. That's going to be B prime. And immediately let's go ahead and check these angles. So B. And it almost looks like it is on top of each other. Not exactly, but it's pretty darn close. And again, we're going to have that 90-degree angle, hence we have a good rotation. Let's do one more. Orange. So we're going to switch it up. Negative 8 gets listed first, and then we change the sign to a positive 8. Negative 4 gets flipped to the back, and we're going to keep it a negative 4. Okay. And so in terms of graphing this, we got to go out to 8 first. So 1, 2, 3, 4, 5, 6, 7, 8 to the right, and then down 4 because it's negative. 1, 2, 3, 4. That's going to be our C prime. Again, let's map the angle. Let's see if this still looks reasonably close to 90. And that's the purpose of mapping this out, is so you can kind of visualize our 90s. And that looks pretty darn good. And it is moving to the kind of counterclockwise there. But let's go ahead and draw in also our new triangle. So A to B prime, A prime, excuse me, to B prime to C prime. And again, this is going to be the hardest to visualize, but if you can kind of imagine like this original triangle spinning in that direction, ending up in this new location, I think that looks pretty darn reasonable if we're orbiting. And again, the key phrase here is we're orbiting, just like a planet orbits the sun to our new position. So it's not just spinning in place, but it's almost like it's on a swing and it gets swung to the right-hand side. Okay, so that's going to be our rotation. Okay, so how should we visualize this? Well, again, there should be circles, and so like I'm not going to draw these in, but if you think back to the original investigate or the warm-up we had, like it seems like a million years ago, but just like 30 minutes ago, these should be on the same circles. There should be 3 circles here that kind of surround them. Again, I'm not going to draw them in; it'll make it too messy, but that's what we should be visualizing. So on rotations, lines that connect, we should know what goes here: the pre-image and the image. That's the abbreviations. To the center rotation. form a angle. Should be an angle, right? Okay, and are same distance. Oh, I see. Okay, to center of rotation form. I don't know. I'm not quite sure what he wanted here. This is Mr. Hancock, so I'm going to put an angle here. Okay, and are the same distance. Okay, from the center of rotation, meaning that since they're on the same circle, the orange lines are the same distance, the purple ones are, and so are the blue ones. Okay, so they form an angle and are the same length. Okay? So again, take a second to summarize this. So while you're summarizing this, the last kind of word I have to say is with a translation, the vector is going to tell you everything. It's going to move up, down, left, right, whatever is going to happen. If you remember the song, that's what they were actually telling you, and this is the details of it. With a reflection and a rotation, though, like these have very specific rules based on how you're doing it. And so like this rule only applies if you're rotating about the origins, 0, 0, 90 degrees counterclockwise. I don't think we wrote 90 here, rotating 90 degrees. That should be here, 90 degrees, because 180, 270, all these other things actually have different rule sets. Same thing with this. Like this is a rule only this rule right here applies only for the y-axis. And so if you're flipping over a different axis or a different line, like this doesn't even apply. And so you're going to need a lot more rules. Okay, so hopefully you're still listening. Because what you need to ask the substitute now for is your cheat sheet. Okay, that's not actually in the substitute's notes to give you, but you have to specifically go and ask for a cheat sheet. Okay, so they have it, the sub has it, but it's going to actually give you all the other rules for rotations and reflections that I don't want to go over because the note's already super long. Okay, so go get your cheat sheet, take a minute or two like mental break, and what you need to do now is immediately put these notes into action. Okay, so the next thing is to go to the activity. We're going to walk through maybe one or two of those examples, and then you're going to have to do the rest on your own. Okay, so you did the warm-up to give you a sense of how these movements look and what you're looking for each one: vectors, perpendicular bisectors, circles, and angles. Now you have seen the details of how to map these in excruciating detail. Sorry about that. And then now it's time to put in action. So go ahead and do that, and then we'll be about done. Thank you.